In our previous video, we used the graphics calculator to find an equation that represented the line of best fit for a linear regression model for our question that I've just popped up just over here. In this video, I'm going to have a look at what some of those values inside of that equation actually represent, and also interpret what the coefficient of determination actually represents inside of that model. So from that video, we found that all linear regression models can be represented in the format of y equals ax plus b, which is also the same as y equals mx plus c, for those that have seen it that way, where a represents our slope and b represents our y-intercept. But if we're thinking of these values in context to a problem, I like to think of these values a little bit differently. I like to think of the b value as our starting value for our y variable in context of the problem, and I like to think of our a variable as the rate of change. So what I mean by that is how much our y variable changes for every one increase of our x. Now in our problem, our y variable represented the yield of strawberries that we had, and our x variable represented the amount of grams of fertilizer that we had. And we found that the equation that best fit the model of data in linear regression was y equals 108x plus 325. So if we were to interpret what the 108 and the 325 actually were in our problem, let's think of it how we thought before. Now our b value is the starting value of our y variable inside the problem. So what that essentially means is this is our yield of strawberries, so this is how many grams of strawberries we could expect if we were to use a 0 gram solution of our fertilizer. Now our a variable here is 108, and that represents our rate of change. So in context of the problem here, for every 1 gram increase in our fertilizer that we used, it had an increase of 108 grams in the yield of strawberries. But these weren't the only values that we got from that video. We also got a r value and an r squared value. But we're going to have a closer look at the r squared value, which is also known as the coefficient of determination. And the r squared value in our problem here was approximately equal to 0.892. Now, the coefficient determination can be used to determine how strongly related two variables are between each other. But it can also be used to explain how much of the change in our y variable, the response variable, was due to our change in the x variable, which is our explanatory variable. And we can do that by looking at this value here and representing it as a percentage. So this value here is saying that we've got 89.2% of the variation in our y variable, so of the variation in the yield of strawberries can be explained by the variation in our x variable, or the variation in the grams of fertilizer used. Now, we can actually take this one step further. If 89.2% of the variation of the yield of strawberries can be explained by the variation in the grams of fertilizer, the remaining percentage of the variation in the yield of strawberries must be explained by other factors. So to work out what percentage is explained by other factors, we would do 100% subtract this percentage here of 89.2%, which is equal to 10.8%. So we can say 10.8% of the variation in the yield of strawberries can be explained due to other factors. So to summarise, the linear regression model, when relating it in context to a problem, we can interpret the A value as the rate of change and the B value as the starting value of our problem. The coefficient of determination can be used to look at how strong the correlation of this model actually is, but also it can be used to explain what percentage of the variation in our y is caused by the variation in our x, remembering that our y is our response variable and our x is our explanatory variable.